Good morning, children. We will continue with chapter 8, propagation of sound waves. Propagation of sound waves. So, we have done till this. Okay, today we're going to start from the next topic, factors affecting speed of sound in a gas. Okay, now before that, I just want to tell one correction. I told you to cut this portion. Yeah, you have to cut only till this. This formula is there. This formula, please put a tick mark. Okay, because using this form, you will be using this formula here. So this formula is included in the syllabus. Okay, now, so we'll start with factors affecting speed of sound in a gas. Factors affecting speed of sound in a gas. Sound in a gas. So remember, this factors affecting is only for speed of sound in gas. It's not for solids or liquids. All these factors that we are going to see is only for gas. Okay. So, to understand this, you should know this formula. Okay. So, this formula, what does it say? Speed of sound in a gas is equal to root of a constant into P upon rho. Okay, this is constant. Capital P stands for pressure and small p, rho stands for density. Rho stands for density. Okay, so this is the speed of sound in a gas. The formula for speed of sound in a gas is square root of a constant into P divided by rho, that is pressure, and rho is density. Okay, the first factor that we are going to see is density of a gas. How does density of a gas affect the speed of sound in a gas? That's the question. Okay. Now, to understand that, we have to see the formula. Now, in the formula, where is density? It is in the denominator. Remember last year itself I told you, if anything comes in the denominator, and then this will be inversely proportional to it. Okay, whichever is in the numerator, that will be directly proportional. So speed of sound will be directly proportional to pressure, and it will be inversely proportional to density, because density is in the denominator. Okay, so our conclusion is speed of sound is inversely proportional to square root of, okay, there is a square root also, so to square root of density. Proportional to square root of density. Now this is how does density of gas affect the speed of sound. So how does it affect? It is inversely proportional to, you can write square root of density itself, square root of density. Now you have to give an explanation. Now how do you say that? You need to support it with some proper reason. Okay. So the reason for that, or explanation for this, is we are concluding this from the formula. So how will you write? We know the formula for speed of sound in a gas is equal to root of gamma P by rho. You have to write the whole thing. Okay, we know that speed of sound in a gas is V is equal to, so from this V is inversely proportional to root of rho. From the formula, I am getting this relationship that V is inversely proportional to root of rho. That's why I got this conclusion. Speed of sound is inversely proportional to square root of density. So, in every factor affecting, you have to see you should be able to answer two types of questions. One is, how does it affect? And then, why does it affect that way? Yeah, reason for affecting that way. Yeah, explanation. It can be in any way. So, you have to write this. Okay, write in words. We know that the formula for speed of sound in a gas is V is equal to, so from this formula, V is inversely proportional to square root of density. Therefore, speed of sound is inversely proportional to square root of density. That is the conclusion. Okay. Now we go to the second factor, that is temperature. Temperature of a gas. Temperature of gas. That is density of gas. First one. This is temperature of gas. Okay. Now the answer for how does it affect? How does temperature affect the speed of sound in a gas? Directly. Okay. Speed of sound in gas is directly proportional to temperature of gas. What do you mean by this? This means if temperature increases, speed of sound in gas will also increase. If temperature decreases, speed of sound in a gas will also decrease. Okay, so I will tell you this. Inversely proportional means if the density of gas increases, speed of sound will decrease, and if the density of gas decreases, speed of sound will increase. Opposite relationship. Now, if I say directly proportional, then so the conclusion is as the temperature increases, speed of sound in a gas also increases. Okay. Now, how do you explain it? You need to support it with some reason, proper reason. Okay. The why of it. We know that as temperature increases, density of a gas decreases. You remember this? If you heat or if you increase the temperature of air, the molecules will move up far apart. They'll move away from each other. That means their density will decrease. Hope you understand this sign. If I put like this, it means increases. If I put decreases. Okay. So first thing is, as temperature increases, density decreases. Okay. So I'll write it in words. As temperature increases, density decreases. Density decreases. And as density decreases, from this formula, you know that if density decreases, speed of sound will increase because they both are inversely proportional. So, finally, my conclusion is as temperature increases, speed of sound also increases. This is my conclusion. Is it clear, children? So, this is how you have to, you should know these two things. How does it affect? It is directly proportional to the temperature of gas, and then the reason for it or the explanation for it, you will start. We know that as temperature increases, density of gas decreases. And from the formula, as density decreases, speed of sound will increase. Now this gives me this conclusion that as temperature increases, speed of sound will also increase. That is the conclusion. So, okay, we can also say V is proportional to, there is no formula. You don't have to know the formula, but you can remember this. V is proportional to square root of T. Okay, now we'll go to the third factor. Okay, there's one more thing here. There is a formula Vt is equal to V0 plus 0.61 T. You should understand this. With temperature, speed of sound is going to increase. Now, for example, the speed of sound at normal temperature and pressure, okay, at normal temperature and pressure is 330 meter per second. Okay, at normal temperature, speed of sound is 330 meters per second. Okay, but we know that temperature is not going to be normal always. It can increase and decrease. Okay, so Um, how do you find it? Okay, this is at 0 degrees Celsius. At 0 degrees Celsius, the speed of sound is 330 meter per second. But every day it's not going to be 0 degrees Celsius. For example, today, right now, if you see the temperature is 30 degrees Celsius outside. Okay, so what will be the speed of sound in a gas today? This value is constant only at 0 degrees Celsius. Today, let's take the temperature to be 30 degrees Celsius. And I want you to find the speed of sound in a gas today. Okay, in a gas means I am speaking in air. The speed of sound when I speak in air, okay, that is also gas. So how do I have to calculate that? They have a formula. V at 30 degrees Celsius is equal to V naught. V naught means speed of sound at 0 degrees Celsius, that is 330 plus 0.61 into 30. Okay, so 330 plus 18, so 18.3. So your answer will be 348.3 meter per second. Right now, the speed of sound in air, like in this, I'm speaking, the speed of sound is 348.3 meter per second. Hope you understand this, children. So the second factor was temperature, and we saw as temperature increases, speed of sound increases. Now we are going to go to much specific things. How does it increase specifically? For that, you should remember this formula. Vt is equal to V naught plus 0.61t, and then you should remember V naught, that is speed of sound at 0 degrees Celsius is 330 meter per second. So if I tell you to find the speed of sound at 30 degrees Celsius, this is how you have to do, and today's speed of sound will be 348 meter per second. Next, we'll go to the third factor affecting speed of sound in a gas. It is humidity. The third factor we are going to see is effect of humidity in the atmosphere. So, you know what is humidity? Humidity is the presence of water vapor in the atmosphere. Whenever there is more water vapor, we say it is humid. Okay. Now, what do you think? How the speed of sound will change in a humid day? Okay. Now, for that you should remember one conclusion. The first is it increases directly proportional. Speed of sound in a gas increases with increase in humidity. That is the, how does it affect? How does the humidity affect the speed of sound in a gas? The conclusion is again directly proportional. That is, speed of sound in a gas increases with increase in humidity. Now let's go to the reason. Now why does it happen? You have to give an explanation. Support this with an answer. Support it with a reason. Now, what do you think about density of, when you compare density of humid air and density of dry air? Try to imagine. Density of humid air. Humid air means air that has more water vapor, and then dry air means no water vapor or very less water vapor. When you compare these two densities, which do you think will be more? Now generally I feel we have this feeling that humid air's density will be more. No, it is less. Remember that humid air's density is less than dry air. Is it clear? So density of humid air is less than density of dry air. So we are talking about humidity. So as density of humid air is less, so density is decreasing, and what will, from the formula we know that velocity, speed of sound will increase because these two are inversely proportional. Okay, so how will you write? Density of humid air, first point you will write is density of humid air is less than density of dry air. We know that from the formula V is inversely proportional to square root of density. Therefore, speed of sound in humid air is more than speed of sound in dry air. Is it clear, children? So 2 points. One is, first point you will mention, humid air's density is less than dry air density. That is, humid air's density is decreasing. Now from the formula, if the density decreases, that means speed of sound increases. So my conclusion is, speed of sound in a humid air is more than speed of sound in dry air. Is it clear, children? So speed of sound in humid air is more than speed of sound in a dry air. Now sometimes, instead of asking this directly, they will ask like this: will the speed of sound be more on a rainy day or sunny day? Okay, if they ask you to compare the speed of sound on a rainy day or sunny day. So, what is the main difference? Temperature is also there, but the major thing that differentiates a rainy day and sunny day is, rainy day is going to have lot of humidity. Okay, on a rainy day, humidity is going to be more. So, and we know that as humidity increases, speed of sound also increases, and the explanation will go on like this. Is it clear, children? Rainy day or sunny day, if they ask you to compare based on humidity. Now, if they ask you summer day or winter day, speed of sound will be more than summer and winter, or winter, that you should do based on temperature. That you should compare based on temperature, because the main factor that differentiates a summer and a winter day is the temperature. Temperature in summer day is more, temperature in winter day is less. But for cloudy day and sunny day, sorry, a rainy day and sunny day, it can be cloudy day also. Generally cloudy day also will have lot of humidity. So cloudy day or sunny day, then you have to talk with respect to humidity. I hope you're clear with this concept, children. Okay, now we go to the fourth factor, that is very easy. That is, speed of sound depends on direction of wind. Direction of wind, effect of direction of wind. So this you could have practically experienced. Whenever the sound that I am producing is in the direction of wind. Suppose I am talking like this and wind is also blowing in this direction, and if somebody is there, then the speed of sound is going to be more. Speed of sound is going to be more. Now, I am speaking in this direction, wind is blowing in the opposite direction. Then what will happen? Speed of sound tends to decrease, because wind will carry some of the sound in this direction. So, this side speed will decrease. So what is the conclusion? Speed of sound increases or decreases according to direction of travel of wind. Okay. So speed of sound increases or decreases according to direction of travel of sound. Then the explanation will be go on like this. If wind is blowing in the direction of propagation of sound, speed of sound decreases, while if it is blowing in the direction opposite, the speed of sound decreases. Okay, so this is a much easy factor. So far we have seen about how these four factors affect the speed of sound in a gas. Now, the next topic, factors that do not affect. There are some factors that do not affect the speed of sound. Okay, factors not affecting speed of sound in a gas. So, here pressure, just underline these factors: pressure, amplitude of wave, wavelength or frequency of wave. These three factors do not affect the speed of sound in a gas. Okay, pressure, amplitude and wavelength or frequency. Now the explanation part of it you don't need, so I'm not going into it for now. Let's leave it. And then we'll go to the next topic, comparison of speed of sound and speed of light. Comparison of speed of sound and speed of light. So this you will write it as difference between speed of sound and speed of light. Okay. So, in air, speed of sound is 330 meter per second. I'm taking normal temperature, that is 0 degrees Celsius. Whereas, speed of light, any idea children? It is 3 into 10 power 8 meter per second. 3 into 10 power 8 meter per second. So, if I have to compare these two, 3 into 10 power 8 is what? 3 followed by 8 zeros, right? 1, 2, 3, 4, 5, 6, 7, 8. Upon, let's take this roughly as 300. 300, okay? So, if I cut it, 1, 2, 3, 4, 5, 6. Speed of light is 10 lakh times more than speed of sound. Speed of light is 10 lakh times or a million times more than speed of sound. That's the first difference you should understand. So light travels much faster than sound. Okay. Then the second point is light can travel in vacuum. Okay. It can travel in vacuum. Okay, I'm not writing everything. You can just mark it. Difference between light wave and sound wave. First point, the light waves can travel in vacuum, but sound wave cannot travel in vacuum. Second point, speed of light wave is 3 into 10 power 8 meter per second in air, which is about a million times greater than the speed of sound wave in air. Then come to the third point, the speed of light decreases in an optically denser medium. Generally, speed of light will decrease in a denser medium. But what about speed of sound? It will increase. Just now we saw it. While the speed of sound wave is more in solids, less in liquids, and still less in gases. Okay? Here not they are comparing solid, liquid, gas, not different gases. So you will write speed of sound is more in solids, followed by liquids, and then small in gases. Then the fourth point could be light waves are transverse electromagnetic waves and sound waves in air are longitudinal mechanical waves. In air, sound travels as compression and rarefaction, that is longitudinal mechanical wave. Light always travels as electromagnetic wave because it has to travel through vacuum. So you know that sunlight, the light that comes from the sun has to travel through layers of vacuum, empty space. So light should be able to travel through vacuum also, and for that it has to be in the form of electromagnetic waves. Remember that, electromagnetic waves. And sound, longitudinal mechanical waves. Okay, so difference between light wave and sound wave, you will have 4 points. Now, based on this is the main difference. Speed of light is 1 million times more than speed of sound. Based on this, you have some applications. Consequences of large difference in speed of sound and that of light. First is thunder and lightning. Again, this is a common phenomena that you would have observed. Generally, when there is thunder or lightning, okay, when it is about to rain and there is thunder and lightning, you will see the lightning first, and after few seconds only the thunder will come. Hope you all have had this practical experience. You will see the lightning first and the thunder will be followed by it after a few seconds. Why? Because speed of light is so high, it can travel so much faster, whereas speed of sound is less, it takes time to travel. That's why you see the lightning first and hear the thunder later. Okay children, so the point is, in thunder, light is seen much earlier than the sound of thunder is heard. Although they are produced simultaneously, they both are produced together, but you see the lightning first and hear the thunder later. Reason, okay, so they'll ask it, this comes as a reasoning question. Basically it comes as a reasoning question. The reason is that light takes almost negligible time in comparison to sound in reaching us from the place of thunder, because speed of light is much more than speed of sound, and you have to mention the values also. Please put a tick mark here. Speed of light, that is 3 into 10 power 8 meter per second, is much more than speed of sound, that is 330 meter per second. Is it clear children? The second consequence is When the starter in an athletic event fires a gun, a spectator sitting at a distance hears the sound of fire a little later while the smoke is seen instantaneously. So, you'd have seen in international matches and all, in international games, for starting, okay, if it is a, say, 100-meter dash, and for starting, what do we do in our school? Anyama gets set, go, okay, they hit one wooden thing, okay, but what do they do in international events? They will give a gunshot, okay, they will not shoot on anybody, they'll shoot in the air, okay. So they are talking about that thing. Now suppose you are a spectator sitting at a far away distance, okay, you will be hearing the sound a little later. You will see the smoke, okay, the smoke coming from the gun. There won't be bullets, okay, just empty smoke will come, but after a few seconds only you will hear the sound. Again, same thing, light travels much faster than sound, and you will have to mention speed of light is 3 into 10 power 8 meter per second, speed of sound is 330 meter per second. Mention the values. 1 mark is given for that. Then come to the third consequence. Spectators watching a cricket match hear the sound of strike a little later than the batsman is seen actually making it. What you see in the TV will be like you would have hit it few seconds earlier, but the sound you will hear it little later. Same reason. Reason is speed of light is much greater than speed of sound, and you have to mention the values also. Yeah, children, you can take the book. We'll quickly mark, and I'll give you some instructions how to write. Okay, so effect of density. First you will write how does density affect. So I've written a how here. Okay, so density, speed of sound is inversely proportional to square root of density. Then if they ask you reason, okay, explain it. How does speed of sound, how does the density of a gas affect the speed of sound? Give reason or explain it. Then you will write like this. From the relation V is equal to square root of constant into P upon rho, it is clear that V is inversely proportional to root of density. So from this formula you are getting this conclusion. So then come to the temperature. First 3 lines says how does it affect. So if they ask you how does temperature affect speed of sound, answer will be speed of sound in a gas increases with increase in temperature. And then the reason, they ask you the reason or why does it affect that way, then the answer will be the reason is that with increase in temperature density decreases and consequently speed of sound increases. In fact, speed of sound is directly proportional to the square root of temperature of the medium. Okay, so this is for the reasoning question. So this formula also you have to remember. Vt is equal to V0 plus 0.61 into T, and if they ask you to calculate the speed of sound at a particular temperature, then you have to use this formula. So here they have shown an example. I showed for 30 degree, they are showing it for 25 degree Celsius. Come to the third factor, effect of humidity. The speed of sound in air increases with increase in humidity. Then the reason from here to here. Density of water vapor, even if you don't write 5 by 8 times, it is enough, it is okay if you write is less than density of dry air. Density of water vapor, humid air is less than density of dry air. Either this or if you can remember exactly 5 by 8 is less than 1. So this will be smaller, this will be bigger. Therefore, increase in moisture in air tends to decrease the density. Okay. So now with the density decrease in density, speed of sound will increase. So what is the conclusion? Hence speed of sound in humid air is greater than speed of sound in dry air. Then effect of direction of wind. How? So this I think I told you before itself. The how of it is given here. The speed of sound increases or decreases according to the direction. Why, or if they ask the reason, then you will write this part. Then factors not affecting. Okay, so not affected, you can circle it. Pressure, amplitude and wavelength or frequency. Now, difference between light wave and sound wave. Okay, I told you, you have 4 points to write in this. Then, consequences of large difference. Again, the question is this, answer will be this. Okay, so the question will be the first part, the answer will be this one. In this too, you have to mention the speed of light, value of speed of light and speed of sound. Is it clear, children? Hope you have understood it clearly. Now, the homework will be question 1 is, Q1 is difference between sound wave and light wave. Sound wave and light wave, 4 points. Is it clear, children? Difference between sound wave and light wave, 4 points. Then, question number 2. These are extra questions not given in the book, so I want you to note it down. Question number 2. Will speed of sound be more on a winter day or sunny day? Give reason. Will speed of sound be more on a winter day or summer day? Okay, sunny day or summer day, give reason. Then third one, will speed of sound be more on a rainy day or a dry summer day? Again, give reason. Rainy day or dry summer day. I have explained this in the video. This you will compare with temperature, this with respect to humidity. So please write these answers and send it to me today itself. Thank you, children.